In this video, I'm going to be going over the dot product. The dot product can be given as vector v and vector w, so this is the dot product here. It's not simply multiplication. How we define the dot product is we say component 1 of vector v, component 2 of vector v, times component 1 of vector w, component 2 of vector w. So when we multiply this, we get v1 w1 plus v2 w2. So that's what we want to remember here. So this is easiest to see through an example, and something to keep in mind is this value is always a scalar. That just means it's a number. It's not a vector with components. So let's see a couple simple examples, and then we'll talk more about what this even means. So let's say I have vector v is equal to 2 comma negative 3, and vector w is equal to 3 comma 4. And I want to find the dot product, so v dotted with w. What we're going to do is we're going to do 2 times 3 plus negative 3 times 4. What we get is 6 plus negative 12, so we get a value of negative 6 here. If we do a second one, let's say vector v is negative 3i plus 5j. Vector w is 2i plus 3j. V dotted with w, we're going to say negative 3 times 2 is negative 6. 5 times 3 is 15. So I get 9. So I want to talk a little bit about how we can interpret the dot product. One way of thinking about the dot product is how much information between two vectors is shared. Okay, so let's just think about this. Suppose I have this vector v and this vector w. And suppose these are 90 degrees apart from each other. And suppose I actually just want to say what vector v is. How about it's 0 comma 5. And let's say vector w is 6 comma 0. Right? So when we look at this, if I was to do the dot product, I would do 0 times 6 plus 5 times 0. And that gives me a dot product of 0. Now, thinking how this relates to this interpretation up here, the dot product is telling us how much information is shared in between these vectors. Well, vector v and vector w, they're not going in opposite directions, but vector v is moving entirely in the positive y direction. Vector w is moving entirely in the positive x direction. So between x and y, there's no overlap. There's nothing from vector w that's going in the y direction. There's nothing in vector v that's going in the x direction. So this 0 here is telling us, well, there's like no overlap in how these two vectors are moving. If we go back to the previous two examples, I'm actually wanting to start with number 2 here. So because the dot product is 9, what that tells us is the angle between the vectors, so between v and w, is between 0 and 90 degrees. 0 degrees and 90 degrees. So anytime we have a positive dot product, that's telling us the angles are between 0 and 90 degrees. If we have a negative dot product, like in this number 1, that's telling us the angle in between the vectors is between 90 degrees and 180 degrees. Okay, so there's 3 possibilities. We could get a dot product that equals 0, like we did down here. And if it's 0, that means they form a right angle. They're perpendicular. Back here, if we have a positive dot product, we're between 0 and 90 degrees. That's separating. And then if it's a negative dot product, we're between 90 and 180 degrees separating the two vectors. So the dot product can be used to help us find the angle between two vectors. So v dotted with w, if we have vector v, vector w, what we'd say is the magnitude of vector v multiplied by the magnitude of vector w multiplied by cosine of the angle in between the two vectors. So theta is the angle between vector v and w. So visually what we'd have here is, let's say I had vector v here and vector w here. Okay, I can find the magnitude of both of those vectors. That would be these values. And then this angle here is the angle in between the vectors. So let's look at an example of how this works. All right, so we have if vector v and vector w are two vectors of magnitude 4 and 7, and v dot w is negative square root of 8, find theta, and that's just the angle in between. So all we need to do is we're just going to use this formula up here. So v dot w, we know what that is. That's negative square root of 8. We have the magnitudes of each vector, 4 and 7, so we're going to do 4 times 7, and then cosine of theta. So 4 times 7 is 28, so I have negative square root of 8 over 28. That's equal to cosine of theta. So to find cosine, or to find theta, we're going to say theta is equal to cosine inverse of negative square root 8 over 28. And typing that into the calculator, we get 95.8 degrees about. So let's just interpret what this means. Well, we saw that we had a dot product that was negative. Like we said previously, if we have a dot product that's negative, that must mean the angle in between them is 90 degrees, between 90 and 180 degrees. Similarly, or I guess additionally, let's look at the graph on what is getting represented here. So we saw that the dot product was negative square root of 8. That is actually pretty close to 0. And remember, if the magnitude is 0, that means the angle in between the two vectors is 90 degrees. So 90 degrees is when the dot product is equal to 0. So this value right here, I mean, it's pretty close to 0, relatively speaking. So that would mean that the vectors, they're close to 90 degrees, but not quite 90 degrees. And because it's negative, that means we have angle or vectors that are over 90 degrees from each other. And what we saw that this angle is 95.80 degrees about. So this kind of, all of this added together makes sense. It all checks out. All right, in this example, we have two vectors, v and w. We have their magnitudes, and it says that the angle between the two vectors is pi. And we want to find the dot product here. So what we're going to say is v dotted with w, that's equal to the magnitudes multiplied by each other. So 2 times 6, and then cosine of pi. Well, cosine of pi is negative 1. So what that means is negative 12 is equal to v dot w. So what does this mean? Well, if we think about this, graphing this, well, if I have this vector that has a value of, or magnitude of 2, this vector, a magnitude of 6, this angle right here is pi. So they're going in opposite directions. Okay, so one way we can think of this is that the vectors are parallel. Okay, they're not exactly like train tracks, how we usually think of lines that are parallel, like this. But if we're thinking about the direction that they're going in parallel to each other, even though they're kind of their tails are lining up. So when we have vectors that are parallel, we'll notice something. So this vector down here, if I write this with its components, I'm going to say it's 2, 0. This vector, I'm going to say is -6, 0. So if we compare these, -6, 0, and 2, 0, what you may notice is that to get from the vector on the left to the vector on the right, I just need to multiply by -3. Okay, so let me back up one sec. If I'm going from the left vector to the right vector, I'm actually multiplying by -1/3. But if I'm going from the right vector to the left vector, I'm multiplying by -3. In either case, if we have two vectors and there exists a scalar or just a constant value like this that I can multiply one vector by to get the second vector, that means these vectors are parallel. So let me write that down. So as a definition down here, we would say that two vectors, say v and w, are parallel if there is a non-zero scalar such that v equals c times w. So in this previous example, -3 was the c value, or -1/3 is the c value. That's just saying there is a value c that I can multiply by to get from one vector to the other vector. If that's the case, these vectors are parallel. So to recap, if we have parallel vectors, if vector v is equal to c times some, or vector w times some scalar c. We have perpendicular vectors if when we take the dot product of the two vectors we get 0. Okay, so let's look at these two quick examples. So in the first one we have vector v is equal to 2, -3. Vector w is -4, 6. And we want to know, are these vectors parallel, perpendicular, or neither? So if we look at these two, to get from 2 to -4, I would multiply by -2. To get from -3 to 6, I would also multiply by -2. So I could multiply, the c value here would be -2, so we'd say that these are parallel. In the second vector, it looks like when I go from 4 to 2, I multiply by 1/2. But if I multiply 8 by 1/2, I don't get -1 here. I would get 4. So these are not parallel. So what I'm going to do is I'm going to check the dot product. So 4 times 2 plus 8 times -1. I get 8 minus 8, and that is equal to 0. So that means that these are perpendicular.